So now let's talk about who would act on that data and why, and what that might do as good for the energy system. So we're working with a group called the Open Innovation Center at Yale, which is one of these groups that creates challenges for mathematicians and data scientists around the world. And kind of the concept behind Swytch is, here is this incredible data set, and if we have people competing to use this to solve problems, we have great crowdsourced brain power working. What are the kinds of problems that get to be solved by this, and what are the things we imagine as we start getting data scientists and mathematicians access to this global data set about energy?
You're basically looking at real climate models, real climate assessment models. You're looking at asset valuations, and so identifying which assets are going to have the biggest impact from a resiliency perspective. You can look at identifying resilient grids, flexible grids, energy storage, how much energy can be implemented on a system in real time, what a distributed energy resource grid needs to look like, what microgrids need to look like, what edge level cases need to look like for demand response, which house in the neighborhood might have the biggest impact from an energy perspective. All of those things are possible, right? So when you start actually sharing information across multiple stakeholders, you can apply, the technology is built in a way where you can change the objective function of the oracle, or these clusters of models, to try to solve for, I wouldn't say an infinite number of scenarios, but you can point it and say, solve for X, solve for Y, solve for Z. And as long as everybody agrees that X needs to be solved for, which is we talk about kind of this decentralized model, then we start solving for X. And so the system allows for this dynamic nature, and again, getting a bit complicated, but it's this dynamic adaptive control, which is what we've been talking about for a while, is now getting a bit into the science. How do we create evolutionary stable states inside of systems? You can't just optimize for one thing. You have to have a co-optimization. So you can't just say, put up all solar, put up all battery. You have to have a mix, and then these models, and the goal of the model is to identify the most optimal outcome for the desired end state. The desired end state is carbon neutrality. Well, then we need renewable energy, we need demand response, we need more efficient systems, and we need connectivity. If the desired end state is resiliency and redundancy, then we need extra batteries, we need extra resources, we need extra solar, we need extra natural gas peaking facilities. So all of those objective functions can be applied in a slightly different end case, and the idea is the data powers the models compete, the models identify an outcome, and they basically submit an answer.